Hello and welcome to yet another episode of Smart Indian Agriculture on the Federal.com. I am Vivian Fernandez. We have a special guest on this show, Dr. Rajeev Varshney, who on the 10th of May was elected Fellow of the Royal Society for his contributions in the fields of food and nutrition. It's an honor he shares with three other agricultural scientists from India, Professor Benjamin Pyari Pal, the first Director General of the Indian Council of Agricultural Research, who is known for his work on rust resistance in wheat, Dr. M.S. Swaminathan, who, with Minister C. Subramanian, ushered in the Green Revolution, and Professor Gurdev Singh Kush, who developed the blockbuster IR36 and IR64 rice varieties. Dr. Varshney is an expert in crop genomics, genetics, and molecular breeding. These are areas India is inadequate in. He is also a prolific researcher with an H index of more than 100 according to Google Scholar, which means he is a highly cited scientist, which again makes him stand out among Indian agricultural scientists. In recognition of the honor bestowed on him, we thought Dr. Varshney would be the right discussant for the topic how to make Indian agricultural education and research relevant. Dr. Varshney, congratulations. It's a pleasure to have you over. Welcome to this program.
Thank you very much, Mr. Vivian Fernandez. I'm very
Call me
much
Vivian, sir.
Vivian. Okay, thank you very much for this opportunity, and thanks for your kind words and also interviewing me. And I will be very happy to share some of our views, especially when I have spent my majority of the career in India. And I would like to acknowledge my colleagues and collaborators from my previous institute, ICRISAT, and our collaborators from ICR Research Institute, State Agriculture Universities in India, but also from other organizations. And I am very thrilled to be the fellow of that Royal Society. So this is very exciting. And yes, as I mentioned earlier, so I will be very happy to contribute in any areas to promote agriculture, crop productivity, agriculture research, training in India. So thank you very much once again.
Yeah, your story is quite inspirational. You did your BSc and MSc from Aligarh Muslim University and PhD from Chaudhry Charan Singh University in Meerut. And after a postdoc stint in Germany, you joined Hyderabad-based ICRISAT in 2005, and you were there till 2022. Currently, you are director of the Center for Food and Crop Innovation at Murdoch University at Perth in Australia. Now, tell me, do you come from a family of academics?
So, yeah, so I do not come from that academic family, but I remember my grandparents, they were smallholder farmers, but my father, he was in that grains dealing business, grains commission agent or so. So I have seen this agriculture, smallholder farmers or smallholding farming very closely. And so, yeah, so no linkages with the academics, but more from that middle class family, and also very connected to the smallholding farming.
I see that you are a prolific, researcher. You also, are a great networker. You also, I've seen you doing an amazing presentations. How do you find so much of time?
Thank you very much. I think all of us got the similar set of the time, 24 hours. And what I learned that we all need to prioritize that, need to see that how we allocate time to the different activities. And I see an important component of the communication. So either this in the form of the presentation or talking to journalists or making or using the social media, because in my opinion, all of us who are doing the research, this is coming from the taxpayers' money. And I think this is an obligation to the scientific community that they need to keep the community up to date, what they are doing, how this is going to make the impact on the society. In some cases, this may be in the short term. In some cases, this may take a little bit long term. So I think because of these reasons, I see a great value in the communication of the science. And that's the reason what you are saying, that I have been making the presentation, even like either TED Talks or even talking to the ministers, talking to the diplomats in United Nations or the World Bank. But I think our job is to keep this society updated and also talking to the policy makers so that they can make that research investment appropriately. And in the end, as we know, health and agriculture, they are the very important thing, and we need to have really good investment in these two important areas.
Mhm. Now, you had a 17-year stint with the ICRISAT, and towards the end, you were heading three global research programs. And one of the important tasks you did was to head a team that did pan-genome sequencing of chickpea or chana. You were able to identify nearly 30,000 genes in chickpea, including about 1,600 previously unreported novel genes. So we have the complete picture of genetic variation in chickpea, which is a very important crop that is consumed in India, Africa, and West Asia. Could you tell us something about that collaboration?
So thank you. And I always have thought from that, I always would like to see the big picture. And many times people, they are doing the genome sequencing in the bits and pieces. What we have done, Vivian, in that when I was at ICRISAT or even when I was in Germany in my postdoc, so we would like to see first that problem, that what is the problem, and then to address that problem, what kind of research frame we need to develop. In the case of chickpea, our objective was not to develop the pangenome, but pangenome was a medium, and we worked on the pangenome to address the issue of the drought tolerance in chickpea. And I would like to highlight this example, and this may take a little bit while, but this is a really interesting story. So chickpea is very important for India. India is the largest producer of chickpea, but at the same time, until 4 years or 5 years back, they used to import chickpea. And you know this thing, I have seen several of your articles that you have talked about these pulses, and India needs these pulses because they are now growing around 18 to 20 million tons. But even if you see from the health perspective, they need 30 million tons. But anyway, coming back to the point, so the crop productivity is very low because chickpea is grown in marginal environments. So the drought is serious thing. Now, how to address that one? You can have the different approaches. Traditional breeding, this takes time. Traditional breeding has done wonderful job. But now we would like to address this thing. We need to understand the genetic variations. We need to understand the genes. For that, we assembled a team of multidisciplinary, multi-institutional scientists from India, ICR, SAU, and other scientists from China, USA, and from other countries. What we did, Vivian, here, we sequenced the big number of lines, 3,000 lines coming from more than 65 countries, and all this research is there. To make this information public domain, we published this paper and in Nature, and this was highlighted by the BBC, by the New York Times, and the Economist, many other thing. But this was not our end thing. Our objective was how to use this research. So what we did, based on these things, we identified some genes which are associated with the drought tolerance. Then we asked the question, which are the superior haplotype for drought tolerance for the Fujiram wilt. And I'm very happy to report to you that based on this research and the information which we generated, we use these things together with the breeders from the Indian Agriculture Research Institute, people like Dr. Bhardwaj, Indian Institute of Pulses Research, at that time point, Dr. N.P. Singh, Dr. G.P. Dikshit, University of Agriculture Sciences, Raichur, JNKVB, many other organizations. And by using the genomic information, we developed the improved lines. And I'm so pleased to say that within this year or by this year, India has released 4 drought-tolerant varieties, 4 Fujiram wilt-resistant varieties coming from the genomics interventions, and where the crop productivity is in some cases 18, but more than 10 to 20% higher. And this is the result of those genomics research in the case of chickpea. So I think these kind of things, and we have developed this thing one time, but now this information is available. And I'm so pleased to see that now these breeders, they are making the regular use of these information, the breeding program. So this is something output from this 3,000 chickpea genome sequencing.
So the genome sequencing is not just of academic value, it has also translated into real gains.
Absolutely. And this has been one of our main thing. And I think one of the things which you mentioned earlier about this Royal Society thing, and they highlighted, they say that there are 2 different kind of scientists in the world who are doing academic exercise, doing genomics, publishing the papers in top class journal, many organizations in the world, and we have been also doing this thing. Second is the breeding, who are just doing the breeding. But they mentioned that, Rajiv, you have developed, or you connected the genomics, advanced genome discoveries, and integrating them in the crop improvement. So this is missing link, and we provided that missing link here.
So you bring a problem-solving approach to your research. You also
Yes,
led the team that did whole genome sequencing of 292 accessions of pigeon pea or arhar or tur.
yes,
How
yes.
has that research translated into action?
So we worked on that thing, and I'm also very much happy to mention that based on this information, University of Agriculture Sciences, Raichur, they have developed one pigeon pea variety, and this name is Bhima, and this is resistant to the fusarium wilt. And also another line is now under trial or so, so there will be this thing. Second is that we also try to understand the mechanism, and I think you and I talked earlier when I was in ICRI said that in pigeon pea hybrid breeding system, they have this 3 lines hybrid breeding system, and we wanted to change this thing to the 2-line hybrid breeding system. When I was leaving, people were working, but now I think ICRI said this is onus on ICRI said, so I think they need to continue to do that kind of work. But we got all these information available in that public domain, and ICR, ICRI said they got lots of opportunities to continue this thing. But in
Mm.
summary, yes, we use that information. Some varieties have already been developed.
Mm. You were able to demonstrate, for example, in pigeon pea, which is a self-pollinating crop, that male sterility and male fertility are temperature dependent,
Yes,
and that temperature modulates sterility, and it is possible to cross pollination. You also were able to determine that there is a particular hormone which, if
yes,
applied externally,
yes,
can result in male sterility and male fertility. Can you
yeah,
just
yeah.
expand on that, and whether, for example, we are closer to achieving
Yeah.
hybridization in pigeon pea?
So that's very good point, and this took a lot of time because we had one line that this becomes sometimes sterile, sometimes fertile, and then in that ABR system you need to have these 3 different kind of line hybrid breeding system. But what we did that through this research, first that we found that this is temperature regulated, and this temperature like below 22 degrees Celsius, then you are having the fertility higher than that one, and then again this was the oxygen. So like from our research we figured out that there are some changes in the auxin biosynthesis pathways. And then to confirm this thing, we took this auxin spraying on that flower, and we showed that, well, even by the external spray, you can do these kind of things. So I think this research was at the laboratory level. Now this needs to go at the commercial level, and I think the companies, they need to work in this direction, and they need to have specialized greenhouses. They need to bring this temperature, and then they can do this external spray. So we have demonstrated at the laboratory. At that time when I was leaving, we did not take this thing at the commercial scale, but this is possible, and we have demonstrated that one.
Mhm. Dr. Vashni, we are in India particularly deficient in oil seeds. Can you tell us your work on oil seeds, particularly on groundnut, and how
Yeah.
you improved the oleic content
Yes.
of groundnut oil?
Yeah. So this is also very important that in the case India, we are having the shortage of the oil seed and mustard, groundnut. These some of these crops, they play important role. And in the case of groundnut, we were doing 3 things. One is enhancing the crop productivity, and for that, what we did, foliar diseases, they play a very important role. And not, I mean that because of foliar diseases, the production goes down. And together with University of Agriculture Sciences, Dharwad, Dr. Ramesh Bhatt, we also developed 2 lines through the genomic information, and they were higher crop productive lines. So these were 2. In case of the oil, because in that oil, when you are talking oilseed crops, if you go in the fatty acid biosynthesis pathways, and if you see the oil composition, then this is having 3 different acids. One is called oleic acid, another is linoleic acid, and a third one is palmitic acid also. Now, what is happening that major normal peanut lines, they are having linoleic acid around 30 to 40%, oleic acid also like this one, but linoleic acid is not good for the health because this represents polysaturated fatty acids. Now, when you talk about the SDG2 from the United Nations, when we are talking about this zero hunger, which includes not only that food, but also that nutrition. If you continue to have that kind of thing, this is not good for health. So what we did, we identified the genes associated with those oleic acid pathways, and then that you can manipulate this thing so that your lines can have higher percentage of the oleic acid and reduce level of linoleic acid. And while doing these things, we developed varieties, 2 varieties, and they were released as Girnar 4 and Girnar 5 by the Directorate of Groundnut Research. I'm happy to share that Prime Minister Modi on that 75th anniversary of United Nations, they put these two varieties as a part of this package of 18 varieties dedicated to the nation. So those things came. I should also mention in the oilseed crop, soybean is very important. In United States and many countries, they were not able to do this thing by molecular breeding. They are still working by using GM and gene editing. But our group, when I was at ICRISAT, we demonstrated that even through genomics and molecular breeding, you can enhance the oil composition. And now the good thing, Vivian, is that now in the groundnut research program, earlier they did not have this concept, but through our research, we have developed a new line, and now many groundnut breeding, this is happening towards the high oleic acid.
Now, in an article in Dialogue, the agricultural scientist and former Vice Chancellor of Delhi University, Dr. Deepak Pantel, said that India has inadequate competency in the areas of genomics, gene discovery, plant pathogen interaction, genome editing and genetic engineering, livestock genetics, and genomic selection in crops and livestock. It's a long list. He also said
Yeah.
that even in non-GE technologies like precision breeding through
Yes.
markers, India is lagging the developed countries and China. Do you agree with what he says? And if so, how do we address this
So,
inadequacy?
yeah. So I think I have read that article, and also I had really good discussion with Professor Pentel, and this was really good synthesis, good analysis. In my opinion, India being a country of 1.4 billion, having more than 106 ICR research institute, more than 60 agriculture university, that's correct, many CSR institute or so. If you see that how many research institute or universities or research program they are working on these aspects, you can count on the fingers, which is not very good in a big country like 1.4 billion people. So that's correct that we need to expand this base. Having said that, there are several programs in IRI, in PAU, in Director of Right Research, or even IIPR. So there are many institutes that are doing this kind of research, but this needs to be expanded. So this is correct. Even in terms of use of the precision breeding in India, except few crops like rice, little bit maize, and some work in our legume crops, we have developed these lines through the genomics assisted breeding, but not many other crops. So this is a little bit sad. But if you compare this thing with China, other countries, or now for many other like Australia, United States, in these things are a bit different because breeding work is done by the companies, industry. But if you, so now here industry, they are using, you know what, we went that they say that any seed which goes to that planting, this is already molecularly analyzed in the lab, and only then we put this thing in that. So that's kind of research they are doing. Now, if you compare with this public breeding program, then probably China is ahead than India. So in terms of use of the molecular breeding, genomics breeding, precision. So what we need to do that we can have to address these issues, I think 3-4 things I will suggest. One is we need to have the educate funding, and we can discuss this thing in a minute, that unfortunately, if you see during last several years, somehow even the low and middle income countries, they are also moving ahead in enhancing their R&D investment as a percentage of the GDP. Small countries like South Korea, Germany, US, of course, big, they are much more higher. But India, we are lower. So I think this is one thing that we need to enhance. Second is we need to develop this base with scientists. And we need to, what is happening, there are good scientists in India, very good scientists, and I have been very privileged to work with several of them. Somehow our system, we need to make the system in such a manner conducive environment, so that if people are doing the research and this will be translated, and when we got this product, they are going to the farmer's field. We know the stories of the GM. You mentioned Professor Pentel, he is still struggling about the GM research and that's hybrid of the mustard. They never reached. So now, but the good thing is the government of India has done wonderful work in terms of the gene editing, so that we should not miss the boat. And we already came up with this policy framework. So I think several things. We need to have conducive environment. We need to have nice policies, framework. We need to have higher research investment. We need to have the training. Training when people are going abroad. And China did this thing very fantastically earlier, Japan and many other countries. I'm talking 20, 30 years back. And now when I go to China, for instance, 2 months back, I was there. If you see the wheat research and those senior people, when you talk to them, they were trained in US or UK. Now there is no need, everyone is trained there. Somehow India did this thing, but not at the system level by pushing some of these people. You can compare this thing like our sports. Some of our sportsmen, they're fantastic when we feel very proud when we bring this Olympics medal, etc. But they are always in that handful. Now, if you see China, they go in the system level, they brings in hundreds number kind of thing. So what my feeling is, we need to have the systematic approach in any of these areas. And I can tell you, India is filled with the talents. We are having really good political will, but somehow these implementations, so we need to work in this direction.
So do you think that as Dr. Painter has suggested, that the Agricultural Scientists Recruitment Board should not restrict its intake only from agricultural universities, but also should take people like MScs and MTechs from other
Yeah.
disciplines, and then about 200 of them, and send them to the best laboratories abroad for doctoral research work, just as China has done?
Yes, absolutely. And for that one, that we should have the lateral entry in the research and also in the leadership position, etc. Because thing is, this is great work and this is great system. But then now, time to time, we need to have this new blood, new ideas, etc. And you can do this thing by this infusion of that lateral stage. So either these are the research institute, they are the research scientists, leaders, DDG, DGs, or N directors. So anything we need to keep on bringing the top class. And I can tell you again in China that what the Chinese people are doing, we do not need to follow everything what China is doing, but we need to follow some good things. The top class researchers who are sitting in United States, Chinese citizen, China government asked them to have their another laboratory in China. So they are basically heading two labs, one in US, one in China. And then this becomes very connecting thing that even Chinese scientists, they are working in the United States lab, bringing those technology, transfer, all these things. And then they're on the higher position. They always would like to see the top person. So, and the same thing is in US, we know it that when they would like to have agriculture secretary or something, whosoever is the top, they don't mind from which state and what is happening. India, they have done something in some cases, but I think this is required more and we need to work in this direction. Fully agree in this aspect.
Now, you have been working with Chinese researchers. Can you tell us, what do you find so unique about them? Yeah, is there something Indian scientists can learn from them in terms of, let's say, collaboration?
Yeah. So Chinese thing, I think this is, so we need to understand. So, well, so in India, we are having the democratic system. So we need to continue to do that one. In China, they are very much top-down approach. So if a supervisor or if a boss told something, they need to finish, they finish it. In India, what is happening, and I'm not talking everywhere because majority of the colleagues I have worked, like IRI is fantastic institute, IAPR, there are several institutes, they're great institute of ICR, they're doing great work. But I would like to see this thing at that larger number. So what is happening in China, even in terms of the funding? If Chinese scientists got a good idea, and in anything, either in the academics or in the applied aspect, and if they pitch this idea to their bosses and say, this is going to happen, they don't ask. And this is one of the things, and I would like to highlight this thing. In India, even during my stint 17 years, when I was talking to the different funding agencies, somehow in India, we have very limited appetite for risk taking. So we are risk averse. They will ask the first question, and this happened with me also 2-3 times. Even very senior people, if you propose some approach, they ask, hey, has it happened? Has Cornell University did this thing in US? Has Europe? I say, well, they have not done it, but I think they are doing it. Then just let them do it first. Let them demonstrate. Then I say, well, this is not the way. If you are doing science, if you would like to have the innovation means you need to be innovative. You may fail, you may be failed. But as Einstein told that if you have never been failed, this means you are not a good scientist. I mean, so what is happening? We are very good in the implementation. We are very good in the following the ideas, but we are lacking in innovation. And I think this is one thing that India needs to do, this thing that how we can be innovative. We need to have the bigger appetite. And I have done several times in my life that I have failed in several things, but I was successful in many things. Many times people see just success, but lots of failure has been behind me. So anyway, so I think innovation is very key thing, which is missing in India. Chinese people, they're moving in this direction. Second is implementation. implementation should be time bound. This is not that if you started the project, you are continuing and then dependent on that, sometimes funding, sometimes this thing. Third thing is finishing. So I think these all the three steps we need to work. Lastly, I would like to mention, and I think maybe because I'm biased, that I would like to see we need to do fantastic research, basic research, no doubt about it. But I think each of us, whenever we are doing some research, if we can frame a question that from this research, what we would like to achieve. And then we do not need to do everything, but then if we like A to Z, we know that I can do A to B, B to C, but we should have this chain, the whole chain, and we need to know that, well, where I can stop and I hand over to the other people. I think this is another thing which is missing in our system, that sometimes, and that's the reason they say that value of death or that, whatever, say that innovation, many times they go down, and then you don't have these basically application. You need some people to bridge that one. So all your innovation ideas or research is not going in that valley of death. You see my point? So,
yeah. But Dr. Varshney, in 2019, the Indian Council of Agricultural Research set up a digital platform for breeding in 8 crops with support from the Bill and Melinda Gates Foundation. It was supposed to be a 5-year program, and the purpose was to double the average yield of 8 crops, which includes jowar, bajra, rice, wheat, and so on and so forth. So what has happened to that?
I think this is a really good project. I was also following that project being led by IRI and several other institutes is working, and this is the digital platform. So basically the idea is, as I was mentioning earlier, so that when you are doing the breeding, so these decisions for making the breeding should be based on that information. This can be phenotyping information, genomic information, data analysis. So I think this is going well. I have not followed during last 2-3 years, but India needs to have that kind of platform, not only for few crop, but for few institute at the larger scale. And I also led several projects from Bill and Melinda Gates Foundation. I was in fact involved in those discussions. At that time point, we worked with them together with Cornell University, etc. So this is a very good approach, and we need to work on this system.
And you may also be aware of the National Agricultural Higher Education Project, or NAHEP, which is a rupees 600 crore project, 5-year project, jointly funded by the Government of India and the World Bank, to not only improve the course content of agricultural education, but also to enable remote learning through digitalization. Are you satisfied with this mandate and the way it has panned out?
So I think this is, again, as I say, the intent is good. And what I would suggest that we need to work more on this implementation aspect. There was some discussion also in this context on this aspect with that with Department of Education or DDG Education with several people, and I also participated in some of the discussion. So, and they're doing good work, but I think what further can be done. So some of these top class universities around the world in agriculture, they can be Cornell, Purdue University, UC Davis, or in Australia, for instance, Murdoch or Queensland or other thing. We need to have a systematic approach, and then can we harness the potential or the expertise of these different universities from United States, UK, Europe, or Australia, involve them in this developing that curriculum, but more than that, that bring those people, invite them, integrate them in our system. So this is something is required. So this is point number one. Second is, and we worked something with the DDG Education, Dr. Agrawal. I also connected him to some of our people at Murdoch. Second is, under the NAHEP, and what is happening, they also have a possibility to send their scientists for the exposure visit abroad. What is happening? They have given the money to the different universities. These different universities, they also spend time to select the people. And I think we need to come up with the plan that we need to pick up the good people, not following that, well, you are my friend or like this kind of thing. That's a different story. Second is, we also need to have some systematic approach. What does it mean? I know from me, myself, and many other colleagues, many scientists, they keep on sending that email. Oh, I want to come for 2 months, 3 months, and then can you give me the placement? And then some scientists gave, some not. What is happening? Somebody goes for 1 month, somebody goes 2 months, and then so, and in 1 month, 2 months, they cannot learn more, or they are not having systematic thing. Rather, the approach should be different university, either they can be have done this thing at the ICR level or the university level. They need to have the MOUs with the different universities. They need to tell from this month to this month, we would like to send our 10 scientists. We would like to send 20 scientists in this area there, so that abroad, these universities, those research groups are also well prepared. They can develop the good program for them. And after that, when these scientists return, they can also continue to have the linkages with that foreign labs, and then can continue to have the mentoring. So I think some of these things are required, but program is good, and we need to see that how well we can do the implementation in India.
And finally, see, in the 1960s, India benefited a lot from Western research in agriculture. And that is because the developed countries, the Western liberal democracies, they were keen to contain communism. Okay. But now
Yeah,
what has happened is that much of this research has gone into private companies. But, Africa needs a lot of help. And in Africa, much of the research now, of the big companies goes into rice, wheat, and
maize.
maize. But
Yeah.
there are what are known as these orphan crops: yam, tapioca, jujubes, and so on and so forth. Don't you think that we should also help the African countries achieve the goal of zero hunger, and we
Yeah.
should help them in research
Yeah.
with the help of genomics and those kind of techniques?
So I think this is a very good question, good point. And there are a lot of political dimensions involved as well. And I think if you see from this perspective, China is already much more ahead than India in this direction. They are already working with many African countries, though they're, and I cannot comment here on this topic, but they went with some other objective, but now they started to work. And this is one of the reasons that whenever at the international level, United UN positions, whenever they are there, majority of time you will see Chinese origin scientists, they are heading the highest level position because of voting system. They have influenced African countries very nicely. I know several cases, even in one of that position of the, for instance, FAO Director General, where some of our scientists, they were also there. They were recently IFAD position, but our people did not get those things, despite the fact that we are so much good in different areas, but here a little bit politics involved. So what we need to do, we need to expand. I know, and many times what is happening, that we are having these good programs. Prime Minister office, Prime Minister, they do great thing, wonderful, but then people need to implement them. Prime Minister office cannot implement everything, right? So they need some implementer. Unfortunately, those implementer we need to find. And what is happening in India, we used to have the South-South collaboration program. So, and this funding, this was available from the Ministry of External Affairs. From ICRI side, I was also involved in some of those discussions, but I don't think that they went to that level where we should have gone. They had some MOU signing with some countries, but top down, this is fine, but we also need to think from the bottom up that how Indian scientists, Indian science can collaborate with Africa so that we can play a very important role. We have demonstrated in 1960s that at that time point, maybe you might have heard this Paul Ehrlich, that he wrote the book that nobody can save India from this crash and like all these things, food thing. But India has come a long way. India is the major exporter of wheat and rice, very well food secure countries. India can show all these things in Africa, especially in the modern technology. And modern technology, not only the genomics, gene editing, even in the agronomy, in the management, in the food processing. So I think this is very much required. And we can gain a lot of political mileage as well. And I think this is also an obligation, especially when our Prime Minister says, Basudev Kutumbakam, I also follow that approach, that we can help, we can extend our helping hand to African countries.
And at Murdoch University, will your research be in the public domain? Will it be publicly available, or will it be patented and then sold to private companies?
So what is happening that in Australia, this is very good question, and a country like Australia, majority of our research, and what is happening, and I will give this very quick example. This, you will be very interested to know that one. So in India, all of our research in the public domain and public funded. What is happening in Australia? Australia is major agriculture export country. Interestingly, you will be surprised that for majority of the crops what they grow, none of these crop has been that native crop of Australia. Australia has brought the seeds and all these things during last 100 years or so, but they have done fantastic R&D that for majority of our crops, the crop productivity is higher than the similar kind of conditions what we have in India. The place where I'm sitting, the Western Australia, here we got the drought issue, we got heat stress issue, we got salinity, we got the cold, all kind of issues. Even then, through the genetics research, our wheat varieties, what we grow, their crop productivity in the rain-fed condition is much more higher than what we grow in India. How this is happening? The farmers, so we call them growers because they are not having the smallholder farmers. Their average farm size is more than 10,000 hectares. This goes up to several 20, 40,000 hectares. And I visited several of these farms. I feel so much overwhelmed. What is happening when they do the export and then profit what they make? 1% of their profit goes for the funding. And this is that one organization here in Australia called GRDC, Grains Research Development Corporation. So this money keeps on going in that pot. This goes in the range of $140, $150 million per annum. And then federal government put the same amount of money in that pot. And then this money is used for research. And not that what Rajeev Varshney wants to do, rather these questions are dictated by the growers that we would like to have the fusion wilt chickpea or heat tolerant wheat varieties. And then GRDC puts the tender. Not that what scientists are interested. They say, we would like to do this thing. Now we are asking Australian scientists who would like to submit their tender, and whosoever is good, we will give this thing. And then the research output, what we do, they are connected to the private breeding companies. For majority of the crops, like wheat, we got private breeding company, barley we got, chickpea we got. So for majority of the crops, some crops, there is still the breeding program in public domain. So what is happening then when we do the research, we publish, so that we put this research in public domain, but the germplasm, etc., what we do, this goes to this private companies, and then they seal the seeds. So like this is the way that things are happening. In my role, I'm working very much in this direction, but I also got another hat, which is called International Chair in Agriculture and Food Security. So through that role, I'm well connected with India, many countries in Africa, and our thing is that research, what we are doing, this is having leverages to the developing countries. So I'm still working with India, some of the chickpea research, I'm working on wheat, that how we can provide the genes, information, etc., so that we can do this thing. So we need to see, IP is important thing, but I'm very much committed for the international agriculture. And this is the reason that I'm having this position, international chair also.
So Dr. Varshney, that was very nice talking to you. You told us how we could go about funding our own research program, why we should have a problem-solving attitude, why we should develop competency, and also why public spiritedness is very important. So on that note, Dr. Varshney, congratulations once again, and thank you very much for making the time.
Thank you very much for this opportunity. I really enjoyed my discussion with you. And as I said, I'm always there to do anything for my country back. Yeah, so thank you very much. Thanks a lot and have a nice day.